How do we know what we know? How do we manage concepts? How do we learn? How do we reason? These are questions fundamental to the study of comparative cognition, how various species, including humans, process information. I'm here with Professor Nicky Clayton of the Comparative Cognition Lab at the University of Cambridge to find out more. Professor Clayton, welcome.
Hello.
Can you tell me, what exactly is comparative cognition?
Comparative cognition is the study of the mental lives of animals, so it's really asking about whether and to what extent animals can think.
And how do you find these things out? What methods do you use in your studies?
Oh, well, that's a lot more difficult, isn't it? Because with humans it's easy, we can talk to one another. What we have to do with animals is rely on their behaviour and try to think about tests we can devise to actually tap in to their natural thinking talents. So you might, for example, ask whether a scrubjay can think about tomorrow and remember the past.
And do you find out that they can? Is this the sort of cognition that they are exhibiting?
Scrubjays are really good at thinking about the past and planning for tomorrow. And the way we look at it is by studying their caching behaviour. And caching just means hiding. So what these birds do for a living, really, is that they hide food. And that's called caching. And we can look at how good they are at remembering what kinds of foods they've hidden where and how long ago and whether other individuals were watching. So that would tell us about how they think about the past. Then we can ask whether they can think about the future, whether they can plan for tomorrow's breakfast, for example. So if you give them a choice of two types of places, let's imagine that they're hotels, there's the Ritz and some sort of rather inferior Motel 6 kind of place. So the one serves a delicious breakfast in the morning and the other, you wake up hungry and you'd love breakfast, but unlucky, sorry, no food here. You give them some experience of both kinds of hotel rooms, so to speak. Then you suddenly give them a novel test, give them the opportunity to hide food the night before. And sure enough, they put all the food in the place where they think that if they end up in the Motel 6 in the morning, hiding some breakfast would be a good idea.
After close examination of these animals, what can we learn about our cognitive processes?
Well, I think one interesting thing is that some of the most dramatic examples of these sort of sophisticated thinking processes come from a very distantly related animal. So the whole idea that you have these, avian Einsteins, these birds with feathers that can think in really complex ways, challenges some of the things we think about the evolution of intelligence, and particularly the idea that it's only humans or our closest relatives, the great apes, that have it. So I think one thing is that the whole idea that intelligence might have evolved independently in very distantly related animals from us, as well as in ones that share some of our evolutionary history with us. So I think that's one thing. I suppose another question is to what extent you can actually think without language, and what kinds of thought processes could you have in the absence of language? Because for us, language is what we do for a living. For a scrubjay, it's caching. For humans, it's language. And so I think in some ways it's perhaps quite surprising just how sophisticated thinking processes might be without necessarily needing to talk about them all the time.
Talking about evolution, what factors influence the cognition processes in animals regarding their environment?
It's an interesting question, isn't it, about how different environments might shape cognition or thought processes. And I guess one thing that my husband Nathan Emery and I have argued is that members of the crow family are as clever as the great apes, like the chimpanzees. In fact, Nathan sometimes calls them feathered apes. And we've argued that actually they had similar kinds of problems to solve. They're very long-lived. They live in complex social worlds where you really need to know who your friends are and who your foes are and how to sort of deal with the political shenanigans of a complex social life. And they also have some physical problems to solve. Some of them use tools, for example, to get food that would be otherwise out of beat reach. And we've argued they probably solved a lot of the same sorts of problems as chimpanzees.
Your current studies suggest that animals, in fact, do make shopping lists. Could you elaborate on that?
Well, I guess it's a sexy title, but the whole idea is that many people have assumed that animals are stuck in the present, that they can't think about the future or imagine the past. I think my favourite example is actually a poem that Robbie Burns wrote called Ode to a Mouse. And in the lament, he's feeling absolutely rubbish. He's racked with guilt because he's just ploughed over a field mouse's nest. And, you know, he sees this poor little mouse wander off into the dusk, into the wilderness, and think, he's going to die. I've just destroyed his nest, and the poor little mouse isn't going to live. And he's riddled with guilt and remorse. And suddenly he thinks, hang on a minute, but I bet the mouse isn't feeling the fear of the future or any remorse or guilt, because the mouse is probably stuck in the present. And he turns to the mouse and he says, still, thou art blessed compared with me. The present only touches thee, but oh, I backward cast my eye on prospects drear, and forwards, though I cannot see, I guess and fear. So for Robbie Burns, and I think for many people, you know, the natural assumption is that animals are stuck in time, that they live in the more or less eternal present. They don't think about the past and plan for the future. And what I'm doing is trying to challenge that claim and arguing that at least some animals do think about the future. So from scrub jays planning for tomorrow's breakfast to chimps saving tools to use for tomorrow.
Okay. Professor Clayton, thank you very much.
Thank you.